SPSS.
Okay.
Bringing that up.
Right.
So, yeah, so basically, my thing right now that I'm still struggling with is interpreting when I read a paragraph, like just kind of connecting all the dots, like what is, well, the null hypothesis, then the alternative, and then anyway, kind of interpreting the data and like what to put where.
Yeah.
And stuff like that.
That's all right.
So let's see. I have up the homework. And I'd love to go over that with you. And then I'm just bringing up the data files.
Okay, that's fine.
Have you already looked over the homework or no?
I looked at it. I didn't do it.
Yeah. It looks
I
like we
assumed you'd
need
do it today.
I did too. Zhang Sim is what we're bringing up.
And MLA.
Okay. Well, is the Zhang one is first. Let's see. So I guess we're starting to create data files now, kind of. Like, and I was watching one of the videos making the difference or something in one of the videos. If that
Yeah, I think we were just doing the average for that, actually. That's what I got from the videos.
Okay.
So it shouldn't be too bad.
Cool.
Hopefully.
All right. It's just loading for me.
There you
go.
Sweet.
We can go on to, okay. All right. Well, just looking over the homework. I even just have the answer key up.
That's what I have.
Yeah, the difference, using the paired data with the testing mean of the difference paired data. Anyway, just the difference is that one is paired, there's 2 columns, and the other is just that it's the individual column.
Cool.
Okay, I am okay with not reading all of it, or we can. You haven't read over.
Oh, did you already read all of it?
I haven't, so we probably should.
Yeah, we probably should read it all.
I'll go ahead and read this one.
Okay.
In the Boy Scouts of America, boys are taught several methods for starting fires without using matches. These methods include striking flint and steel and touching a battery to steel wool. A scoutmaster wanted to know if there was a difference between the mean amounts of time required to start a fire using 2 methods. He asked 6 randomly selected boys if the scout troop to make 2 fires each, for them to make 2 fires each using one of the methods for each fire. The scoutmaster recorded the time in seconds for the boy to start a fire using these 2 methods. The data are given below. Assume the times required to start the fire by these methods are normally distributed. Okay. Use the information below. Explain why this is an example of paired data. Well, things that we're comparing to.
So the answer says this is an example of pair data because knowing the subject of the first experiment, flint and steel, determines the subject of the second experiment, battery and steel wool.
So because there's two things that we're comparing against.
Yeah.
Kind of.
Mm-hmm.
All right. Create and interpret a 95% confidence level for the mean difference in the amount of time required by the two methods.
Sweet.
Okay.
Well, do we have to plug these in
So,
on SPSS?
okay, and is this in the,
No, it's not. We have to type it in.
okay. And can you share your screen?
Yeah, I'm just trying to pull up a blank sheet really quick.
Where do you go to pull up a blank one?
You just click on the SPSS link.
Okay, I'm just where all the data files are. Oh, right at the very top.
Yeah, go
The
to File.
SPSS. Uh-huh.
And then
The
New and Data.
just a second. So are you finding it in the, like, where all the other files are?
No, I'm just opening up a new one if it lets me. Let's see.
See, I don't know how to do that.
It didn't want to let me open up a new one, so I'm going to open up another one. And usually the first thing that pops up is just a blank one. I got a blank one. Cool. Ah, dang. Well,
Oh, so in the, like, if I'm in, even in the Zungzim, I open up file, then I go to new, and then we're doing a data.
Yeah.
Okay.
Okay, so do you want to
I've
read
got a
me
blank.
the... Okay, so I guess we can just both put them in. 54, 66.
Okay, so can I see what you're doing?
Yeah.
So I'm doing it right?
Why isn't it letting me do anything? Is yours letting you type in more than one letter or number?
Yeah, like just in the cells.
Yeah.
Yeah,
Mine
like I'm
won't.
able to type in the 354.
I can't do that. Let's see.
So would I just go across? I wish I could share my screen.
No, go down.
Just put
The
all of them
flint and
down.
steel is one, and the battery, or and the battery and steel wool is another one.
So in one column, I put all the flint and steel ones, and then in the next column, I do all the battery steel wool ones.
Yeah. you want.
I'm just swapping just so. Okay. So that's what you're talking about.
Yeah, hold on. 205. Okay. I'm talking about. What were you swapping?
Okay. Oh, then here, do we copy this and then paste it into something, or are we just purely creating a new one?
We are going to make a. We're gonna do the confidence intervals. So you go to analyze, descriptive statistics. I think
Explore,
is it explore? I don't remember.
or are we?
Are we finding the confidence interval mean difference about the time required for the two methods?
And it's 95. Okay. Well, so do we pull both of them over then?
Yes.
Okay. And it's the statistic is at 95%. Okay. So let's see if I got it right. Let's see. There are two possible correct solutions depending on the order of subtraction.
Let's see.
Confidence interval. Lower bound, upper bound. Okay. Well, my lower bound and upper bound are very, let's see, different than
Do
what
you
this
have?
says.
So do I.
The 130, do you have the lower bound 130?
I do have the lower bound 130.
Yeah, so I don't know what we're doing wrong here.
Let's try doing it by hand. It's 354.
Are you first just going to put them all in and then
Divide by
find the
6.
mean, divide them by how many
Yeah.
there are?
Plus 100 plus 287.
Six. Well, my first one is not.
Okay. 2,
Uh,
we need a T-score. Actually, maybe we don't.
Okay.
Yeah, it's okay.
So, Catherine, can you talk me through what you're doing?
I'm just doing it by hand to see if I get it right, and then if I get it right, I'll tell you what I did, just so I don't
Thank
confuse
you.
you. Nope, I didn't get it right. Let me see if I can do. Do they teach you how to do this on SPSS? Paired samples tube test. All right.
Were we supposed, well, we weren't supposed to plug this in somewhere because one of the videos I watched was we enter in all the data and then we copy it and paste it into somewhere, but I don't know where
Really?
we would do that.
So there's one pair with two different variables, right?
Yeah, aren't there? Just because there's the two things we're working with?
Okay, so.
Or do we need to find a third column and put in a difference?
I got it. So what you're going to do is you're going to go to Analyze.
Okay.
Compare means.
Ah.
You're going to go to Paired Sample T-test.
Oh, there you go.
And so variable, it's going to be pair 1, and variable 1 is going to be our first column, and variable 2 is going to be our second column, just for that one.
Now, do I put variable 2 over?
No, you put variable 1 and then variable 2 right next to it. There's nothing under it.
Okay, just right next to it.
Mm-hmm.
Just like, let's see. Oh, wait, it didn't go over, but yeah, over to the side of it.
Mm-hmm.
Okay.
So we can get either one depending on which one we did.
Oh. The pair must contain two different variables. It won't let me put it right next to it. I wonder if I have to
click on it and then go back and try it again.
The pair must contain two variables. It's wanting me to put it underneath.
Yeah, you have to click on the one right next to it, and then click on the little arrow twice or something like that.
Let's see. I don't know how you put it in.
Okay, so
you didn't put it underneath?
No, so my first one, I am going to, okay, and click on the second one. That's all I just clicked on the first one, the arrow, and the second one, the arrow, and it went straight to the side.
Okay, so I'm trying to bring this one over into this section, correct?
Yeah, try dragging it.
Well, that's what I'm doing.
Okay, so what are you gonna do? So let go. So click on the arrow.
This?
Yeah. Okay.
Okay.
Now click on
Now do it.
one. Yeah. And the arrow. No, don't drag. Just click on the arrow.
Oh,
Yeah.
okay.
Okay. And
And
then now
then
click
this.
on the second one and then the arrow.
Oh, beautiful.
Yeah.
Beautiful. Thank you.
Mhm.
Okay, and then you just pushed OK.
Yes. I did.
All right, and then let's see here. Where's the All right, and then to find the, because then we end up down at the bottom, but we need to find the confidence interval for 95.
Mhm.
And that's probably up here at the top.
For number 3? We already did number 3.
Or,
It can either be the one we got or another answer.
okay.
So it's, yeah. Because these zeros contained in the confidence interval. So if 0 is in the confidence interval, then the evidence is inconclusive? Is that what this is saying?
There's an inconclusive evidence that there is a difference between the methods since 0. That's what it's saying.
Oh, yeah, I guess we do everything, the mean compare it to 0, since that's the null hypothesis.
Okay.
Cool. All right, let's go on to number 5. I'll read it.
Yeah, do you want?
The Zung self-rating anxiety scale was developed by William W. K. Zung, a psychiatrist from Duke University. To quantify and compare anxiety levels, higher numbers indicate higher stress levels and lower numbers represent lower stress levels. Many stress relief courses use this scale to measure the change in participants' anxiety from before the course to after. If you want to determine if a particular course is effective at changing stress levels before you consider participating, open the file and define the differences of the individual Zung score after the course minus the score before. Use information to answer questions 5 and 16. All right, so.
Hey, is your headphone clicked in all the way? It's very echoey.
Yeah, do you want me to try it without? Probably because, oh. Is this better?
Super.
Okay,
Yeah.
my speaker was kind of just hanging.
Okay. All right, so I'm in the Zim. And so for this one, we're just going to go into the analyze again.
Yeah, and do a paired sample t-test.
Or go into the compared means. Okay, and bring that over again. Okay.
There you go.
Okay, then the confidence interval, the true mean difference before after stress. Okay, where do we find that negative 2692?
So I got that, but I got the opposite. But where are the 95 consistent true mean? I got negative 0.025 and then 2.69.
I don't see those anywhere.
Did you do insert or analyze, compare means, paired sample t-test?
Yeah, and then I just brought those two over like you showed me with the arrow.
I think.
And then I just pushed.
Let's see. Before treatment and then after treatment. Maybe we have to do it the other way because it wants to know the difference before
Like
and after.
through descriptive and explore?
No, so let's see. Where is it? Go to analyze, compare means, paired sample t-tests, and then do.
Oh, I put B in the first slot. I wonder if that had anything to do with it.
Probably.
Let me see, because A was underneath it.
Okay.
Okay, let me try this. See if it gives it to me.
Oh, I think it says after the course minus before the course. So we have to listen to that. That's why we're getting the wrong answer. So you go to analyze, compare means, paired sample t-test, and you do the second variable before the first one since it tells us to do.
Yeah, I got it this time.
Okay.
I got it in the lower and the upper.
Cool. So did you get negative 2.69 and 0.024?
Yeah,
okay.
It's right there.
Sweet. Since.
Okay. Number 6. Does the confidence interval contain a 0? If so, what does that tell us?
It is possible that the true mean difference is 0, meaning that the class could have no effect on stress levels. Okay, so if it has 0 in it, then evidence is inconclusive. That's basically what it's saying.
Where is the, let's see. Where's the like, I'm looking at that. I mean, we have the numbers, the 95 confidence interval, but where, is there a place? Because in the other one, there's a place where it just has a 0.
No, so in between our intervals, 0 is in between those, and that's what it's talking about.
Oh, got it.
It's not something you solve.
Okay. Okay, so it is inconclusive. You also want to conduct a hypothesis test to get a better understanding of the evidence of this course and test to see if there's a difference. Use a level of significance of 0.05. State the null and the alternative.
That's easy. All right, we're still on the same one. Make an appropriate graph of the data. So it should be, a histogram should be of the differences, not the individual data sets.
Okay, so to make a histogram there, do we go into, let's see, graphs?
Analyze statistics. I think we go into descriptives. We do.
And then explore, or no. Analyze.
Style. Cancel. Nope, that's not it. I'm trying to remember how we. Oh,
go to plots. And then do histogram. Go to analyze, then descriptive, then explore, then into histogram.
There's histograms there for you?
It's descriptive.
Uh-huh.
And then, let's see if it comes up.
I remember we did it once.
Okay, so I'm starting over. So I'm going into analyze, I'm going to descriptive, then explore, then I'm going to plots, and I'm clicking on histogram.
Oh, explore, okay. Which ones did you pull over?
Oh, whoops, I haven't pulled any over yet. Should we just pull over both of them?
Yeah, I pulled over both. Um,
Okay, let's see what happens here. See if I get this picture that I.
it's not.
Mm-mm.
We need the differences, not the individual data sets. So we do, let's try this.
Do you think it depends on what order they're put into the dependent box?
No, let's see. Compare means. I'm going to try a different way really quick. So options. Um,
Normally, because they're normally normal plots with tests. I'm going to click on normality because it said that they were normal. See if that changes anything. Did I get it? So it should be the difference, not the individual. Oh, it says the differences, not the individual data.
yeah. So oh, holy crap. I don't know how to get the differences on SPSS.
Ah,
Is
wish I
it,
could meet with.
I know that you can do it by subtracting every single one of these, but I don't want to do that.
Mm-hmm.
Let me
Well,
look on Google.
okay. It's kind of nice getting this out of the way.
Yeah. Let me different option. Ooh. Let's see. Um, well, that wasn't very much help. Let's try this. Explore. Hmm. I don't know. It's a good
I'm
question.
wondering, trying to check out. I want to Wonder if the videos or something.
I don't remember seeing any of this on the videos. It's all right. We can
know.
probably guess on the quiz which
Yeah.
one it is. Let's just skip that one for now.
Okay. Because yeah, like I watched all the videos, the Cromer and the redhead guy,
And I didn't see any of this.
yeah.
We can probably just figure it out. All right, 9, verify that the requirements to conduct a hypothesis are met. So we assume that the data were collected using a simple random sample, and we have a large sample, so we can conclude that the distribution of sample means is normal. Okay. Give relevant summary statistics, mean standard deviation, sample size.
Well, that would be if we
We've
have the
already done
right.
that.
Yeah.
So let's see. What is it? Oh, dang.
Pour the sample.
There we go.
Well,
So the mean is,
oh, go on.
I was gonna say the mean is 1.33 or negative 1.33. Standard deviation is 4.01426. And the standard deviation is, that was the standard deviation. Then the sample size was 36.
36, right there.
Yeah. Okay, and then the T was negative 1.993. Was that it?
Yeah, that's right.
And the DF is 35. So all these answers just come from SPSS.
Yeah. Where's the T at? Let's see.
It's in the where it says paired samples test.
Is it? Oh, there. It is. Wait. There's a couple. Oh, there it is. I see it.
Okay.
Okay. Sketch the sampling distribution showing the test statistic and shading in the P. They saw that this only do they want us to use the applet?
I don't know. Nah. If they do, then we can just do whatever they did here.
Yeah.
Uh,
State the p-value. Does it show the p-value on here?
the p-value is the standard error mean. Is that it? And you divide it by, oh no, it's over here. The sig two-tailed.
Oh, yeah, yeah. And then if it's one-tailed, you divide it by 2.
Yeah, you divide it by 2.
If it's two-tailed, you keep it.
Mm-hmm.
So is it two-tailed? Let's see. Is it below?
It's two-tailed because it says the difference.
Okay. So we just keep it.
Mm-hmm.
Where's that sig at?
That's the very last one.
Okay.
Right.
Well, before all the plots.
Yeah, yeah.
Here we go, right here. Okay.
Okay. And so you ready for 14?
Yeah.
Okay, so give the decision rule for the test. Since the p-value is greater than alpha, we fail to reject the null hypothesis.
Yeah.
Cool.
Because it's above.
There's insufficient evidence. Okay.
Correctly, you would have gotten the same conclusions between the hypothesis. Why do you suppose the conclusions are the same? The conclusions are the same when we do 95% interval and a two-sided hypothesis test with a level significance of 0.05.
That's
Okay.
exciting.
Let's do the MLA thing.
It's the same thing. Do you just want to go on to the quiz?
Yeah, I
Okay,
do.
let's do that. We can figure it out.
Let's see. I'm gonna open up my quiz in SPSS.
Quiz.
Okay, let's see. Group meeting quiz 12. Oh my gosh.
Yeah, I'm gonna open up these files. Okay.
I'm getting them as well. Okay. Okie dokie. Suppose we have a set of paired data and let the D equals X after blah, blah. The null hypothesis is this. So how do you say that's the mu over the difference or the.
Hold on. I'm still pulling up the other one.
Okay.
Didn't want to.
Jordan collects a sample size of n. What is the value of the test statistic?
Got it. All right. Okay, true. So I think they just want the t-score, right?
Okay. Yeah.
Suppose we have
And so do we.
set of pair data. After D is after minus before.
Do we run it through that chapter 12?
They gave us an equation for the t in the videos, right? So it is t equals g bar minus the null hypothesis over the standard deviation over the square root of n. So d bar is 2.2. The null is
is 0.
Standard deviation is not
Um,
known.
yeah.
N is 9. Why did they tell us?
Oh, here it is.
Did you find it?
No, I just found the equation. I just was looking through my notes.
Okay.
So how do you when the standard deviation isn't known, what did you do?
Well, the thing is that we have two unknowns. Rotating touches is greater than Jordan's. Use a probability to determine the p-value for Jordan's hypothesis. Okay, let's skip 3 and 4 and let's go on to 5. And figure that out at the end.
Sounds good to me.
Okay.
Let's see. Now we use the A. Okay.
What is it? So we're going to use the paired sample t-test. Be sure that the test does group 1 minus group 2. Okay.
I'm going to compare the means, paired sample t-test,
Mm-hmm.
and
So
then,
it says group 1 minus group 2.
so group 1 is first.
Mm-hmm.
Okay.
Did they give us an interval somewhere here?
The lower and the,
All right, so
are we talking about the 31.4061? Lower?
we're just looking for t right now.
Oh, yeah.
So t is 0.407.
What's that?
The p-value, is this a one-sided or a two-sided? It is a two-sided. So if the p-value is 0.689.
Oh, wait. Where is that sig at? I'm having a hard time finding.
So did you do the t-test?
Yeah, I did the t.
It's just where it says mean, standard deviation, standard deviation, error mean, lower, upper, T, DF, sig.
Oh, right there. I got it.
Okay.
I got it.
All right.
Okay, just a second. So we're doing, oh my goodness. I left all these other ones open. Okay, so for the t-test, what was it again? Did you already put it down?
Yeah, I did. The t-test is 0.407.
That's for the test statistic,
Mm-hmm.
0.407.
And the
P-value?
yeah, I did. It's 0.689. And then on 7, since the p-value is greater than the level of significance, we reject or fail to reject.
Fail to reject because we're above.
Mm-hmm. Okay. Suppose the alternative hypothesis is that instead, what is the correct decision based on the evidence? We have, if you fail to reject, it's insufficient evidence, right?
So insufficient evidence that the it's greater than the second one.
Yeah. Right.
Okay, now we do the other one.
Okay, so let's just do the t-test for that one too. It's for B, right? Or A?
Yeah. B. This one's for B
This
now.
is B, okay.
Okay, so to do the t-test, I'm going to analyze. No.
This one says be sure to minus group 1 to group 1 minus group 2. Okay. So 1.
Oh, don't you type that in somehow?
Type what in?
Like, don't you bring it over and then I watched some video on that. Let's see. Let's just do it.
Well, we got it right doing it this way, right?
Yeah. Let's see. So go to compare means, paired sample. Or
Yeah.
we're doing a paired.
Why is it?
Okay, and is it group 1 minus group 2?
Yeah, it is.
Okay. All right.
Okay, which is greater? N is greater.
The sample is the N, the 22.
Mm-hmm. Is greater than 21.
Okay.
P-value. This one is
Oh my gosh. It's annoying.
oh,
Okay. Sorry, I'm still on question 9. So which is greater? The n was greater.
yeah.
Come on. It's not letting me click on it. Oh, there. Okay. And then let's see. Do you have it pulled up?
I do.
Are you looking at the p-value?
The p-value is 0.001.
Decision. We
Smaller, so we
We've-
reject.
so reject.
Don't know
We
hypothesis.
reject it.
You decide to try another alternative. This time you use that and keep the same level of significance. Did the p-value increase or decrease? It decreased. Because we're going to divide it by 2.
Yes, because it becomes a one-tailed.
Okay, so it decreased and we still reject.
Because it's still below.
Mhm. So based on your response in the previous question, we have sufficient evidence that there is no mean difference between two groups, so there is a difference. It's insufficient evidence. What is the question asking for again?
Based on your response from the previous question, what conclusion do you make? We have insufficient evidence that there is a mean difference. No. Maybe the last one?
Well, since we rejected, then we have sufficient evidence that there is a mean difference between the two groups. And yeah, I
fourth?
think it's C.
C?
If not, then it's A. We can always fix
Okay,
that, but I'm
well.
pretty sure it's C.
We have a few chances.
As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? It's B. Or
Not enough.
B or D.
Or
Those are the
B.
same.
B or D?
Yeah,
It's
because
greater
both
than and less than.
yeah, B and D are you both divided by 2. So A is the biggest and B and D are the same answer. So do we just put just depends on the problem?
Should we go for that?
Yes, I think that's the best answer.
Because those two kind of cancel each other out. 'Cause they're the
Yeah,
same.
like we have to know what the p-value for those are.
Okay. Determine the 95% confidence interval for the mean difference between the two groups. Input your answers. What is the point estimate for this 95% confidence interval? Let's see.
Point
Where are
estimate.
those at?
Did they give us that?
I don't know. Where did mine go? Oh my goodness. It's like they disappeared.
Oh, this is the interval. So we put our 5.303 parentheses 5.303 comma 18.607.
18.
0.607.
Okay, so in your question number 6, you put 5.303 comma 18.607.
I put 5.030. Oh, it's 303. Just kidding.
I have 5.303 comma 18.607.
Yeah. I don't know if we put a space or not. I don't know if it doesn't matter. See on the
Or
homework.
dash. I'm not sure.
Homework
What is
does.
the
They have a space. Let's do a space. Maybe after the comma.
After the comma.
Yeah.
Okay. And then the margin of error. Okay, do we just use those and do the margin of error?
So the
Formula?
margin of error is the t standard deviation, or SD over n.
Oh, and we're doing the 95%. So it's the
You don't
one.
need that.
Oh,
Do you remember that formula? It's the second half of.
oh, just the because normally the margin of error for the confidence is the percentage. So like the 1.905 times standard deviation over the square root of sample means, right?
I don't remember.
At least in my notes, that's the margin of error.
It's
one.
Probably right. Yeah.
What's the standard deviation?
This is SD, which is different.
Oh, yeah.
I think it's 15.003.
15.03.
Divided by the square root of 22. For this 95 confidence interval. Do we use the 1.96?
I don't know. If I did,
That's probably right. I think we do.
Can you see what I did?
I'm gonna go to your screen. Yeah.
That look right?
We can do that, and if not, we can change it.
Okay.
1.96.
At the 6.281.
Times 1.96. Yeah, 6.269. That's what I got.
6.26. 6.261.
6.26. No, it's 2.269. 6.269. If you were to round up the 9, then it'd be 6.27.
Okay, so what are you going to put down?
It's 2.269 since the 3 isn't bigger.
2.269.
Oh, this one's an interval.
Or
this one's the margin of error for this confidence interval. What is the point estimate? I think we have 16 wrong. Let's see, 6.269. I don't think 15 is asking for an interval anymore. Let's see, should we find point estimate?
okay, the point estimate one is no, in my notes. Let's see. I don't know. I just wrote this down. Like it was asking after. Let's see. This one. Okay. In my notes, I have the point estimate, and then it does show that, at least in my notes, that I give two numbers with a comma. At least that's my notes I took.
Really?
I have like a page of different formulas. And for mine, it says point estimate. And what I did is plus or minus, and then I did parentheses. Maybe I need to do it in a parentheses, the whole thing. Maybe that will change it. And then I did the full, then what we just did, the 1.960 times the standard, and then that, and it, at least in my answer here, which equals with a comma in between. But I don't know. I mean, that's just what I wrote for my.
Okay, so what would you write for 16 then? Would you write what we have right now? Or are you solving for the t equals?
Well, how did it get that? Oh, how do we plus or minus it? Because somehow we had to get the two different
Yeah.
answers.
So
Because
yeah.
we'll go on. Because why is that the same formula?
Don't know. I know 17 should be right.
I think so too. But somehow with that same formula, I have written down plus or minus. I'm wondering how I would plus or minus and what we would plus or minus.
Let's see. I'm looking online really quick. Is a population parameter. So point estimate of a population parameter is a single value used to estimate the population parameter. For example, the sample mean of X bar is the point estimate of the population mean U. So is the point estimate 0?
Catherine, let's see.
I wish we had a question like that on our homework.
I know.
We could also take this once, and then once everyone else takes it, we can edit it a little bit on our second try. Do you want to try that?
Because we could technically, both of us have a try at it, and then we don't do our second tries until Eddie and Donna have met.
Yeah.
We could email them our answers, and they can, showing we didn't get these wrong. What did you guys get?
All right. We can do 18 and 19 though. We have those. 5.303. 5.303. And 18.607.
Is it just those?
Yeah, so our 16 is wrong.
Yeah. So, okay, but the lower two is the 5.303 and the is
18.607. Mm-hmm.
18.607. So what do you do for that?
No, I put 0 for now. Or group 1 minus group 2. Is it group 2? Group 1 minus group 2. So I think we subtract. Do you subtract 5.303 from 18.607?
And then find that.
607 minus 5.303. 13.304. I'm going to try that. 0.304. We still have to do 3 and 4.
Yeah. What are you putting down in the point estimate? The 13.304?
Yeah, I put that down.
Positive 13?
No, I'm not positive, but...
No. I mean, it's a positive.
Oh, yeah, I put it at positive.
0.304. That just seems too easy almost.
Yeah, I don't know.
I always think things should be like harder than what they need to be.
Well, if it's wrong, we can always ask them.
Yeah. Okay, so let's see about these ones. The test statistic value. Well, because we didn't have a
standard
D,
deviation.
Right?
We didn't have a sigma.
Or a sigma, yeah, to use.
Did you write down all of these equations down?
I just wrote down from the notes of taking from watching. I just wrote down the one sample T and the paired sample T.
Okay, so is there a formula for sigma being unknown?
I don't remember anything about that. I know, like, to find the sigma.
Is there a formula to find sigma?
I don't remember watching one. I wonder if you could flip
Oh.
some things around to
Hold
do
up.
it.
I think I got it.
What'd you do?
So it's going to be 2.2
Just
actually that's plus or minus t, which is what we want, with 3.3 over the square root of 9. I have no idea.
shoot.
3.3 divided by 3, and then 2.2. Is it 2? The value of the test statistic? I'm going to put 2.
All right, I'll go with that.
Okay. And so
And the probability obtaining greater than the test is, use the probability to determine. We can use, if we have the test, you're just putting 2 in the test statistic?
well, the thing is that we're finding the p-value for this one.
Yeah, but for the test statistic, you put 2.
Yes.
Because we can use the applet.
For this? Oh yeah, it's a z-score, right?
Yeah. And whenever we're doing the p-value, we can do
So the area is 2 then.
the t-score is 2. So the
So
area is the 0.045.
0.045. Maybe that actually, so half of that. It would be half that.
Because it's the 1t. So take the,
Because this wants to know if it's
what was it?
greater than
0.0455 divided by 2.
0.0455. Yeah.
And that's 0.0228.
So 0.028, 0.023.
Yeah.
0.023.
0.023.
Mm-hmm.
I missed a 0, putting in a 0 in one of my answers and just the other day. And anyway, the teacher's really good about giving you those things.
Yeah,
I just emailed her and she's like, oh yeah, you can have it.
that's nice.
Okay, so you've got down for 3, 2, and then 4, 0.023, 0.407, 0.689, fail to reject. We have sufficient B,
Mm-hmm.
and 0.001, fail the null hypothesis, decrease.
For 11, I have reject the null hypothesis.
Yeah, sorry.
Okay.
I have that down too. I don't know why I said otherwise. 13 is also reject.
Mm-hmm.
14 is C.
Mm-hmm.
Not enough. 13.3042. Should we
0.304. Just
4?
yeah.
Yeah, leave that. I guess just one of us will click on this anyway.
Mm-hmm.
6.269, 5.303, 18. Oh, I have 2. periods in here. 2 points. Do you want to click on it first or me?
Yeah, I'll do it. And we'll see what's up. All right, we got question 3 right, so it was 2. We got
Good.
4 wrong. Let's see what we got at the end. We missed 3. Okay, so the ones we got wrong are question 4, 16, and 17. So we should probably wait until Donna and Eddie do it.
Yeah.
Because I don't know how to do any of those.
Mm-hmm. Okay. Well, if it gets really bad, because when is this?
It's due
This first
Tuesday.
one's due Tuesday. Because what I was gonna say, like, even if they're not able to, I meet every Tuesday with the TA, and so not that, I
Okay.
mean, I'm okay with getting one wrong, but if we want to get 100%, I could go over the whatever questions we all collectively 4 of us couldn't figure out.
Yeah. Okay.
But hopefully they'll be able to figure it out.
Yeah, I'll look into it, and because I still have to do the homework quiz anyways, so
Yeah.
yeah, and I'll let you know.
All right. Thank you very much.
Yeah, I'll see ya.
Okay. Okay. Bye.
Bye.